Hello dear children, how are you all? Hope you all are fine and doing well. My name is Naresh, welcome to our channel Physics Plaza. So children, in today's session we are going to start a new chapter, reflection of light. Children, I have one question. Can we see the things? Then we can say that of course we can see the things. But here I'll ask you one question. I'm very sorry to ask this question actually. There are two persons. A healthy person means whose eyes are working properly, and one more person like a blind person. Who can see the things? So definitely we can say that the person with a healthy eyes only can see, and a blind person cannot see the things. Actually we can say that. But dear children, I have one more point here. Whatever the like a person which we are saying that he can see the things, let us say ourselves. Let us take ourselves. Yes, we all can see. Now I am able to see you all and you are all able to see me also. It's correct. But thing is that let us imagine a situation where we all are in a dark room. Where we all are in a completely dark room. Then can we walk properly? Just imagine situation, dear children. Suddenly in our house also sometimes power will go off. How will we be walking? Do you think that normally we will be walking? It is not that. We will be walking like this. Like this we will be touching and we will be going. Means though we have eyes, children, remember it's very important. Though we have eyes, we cannot see the things. See, then we also will become blind. Become blind. Which means what? Eyes alone cannot see the things. Please write down. It's very, very important. Eyes alone cannot see the things. Here we need some external energy which is needed. That external energy which makes the things visible so that we can see the things is called actually light energy. It's very, very important. It's very, very important. But one more surprising thing about light is that actually light is invisible in nature. What is this? Yes, yeah, it is like a god. Light, energy. See, in physics we can call it as energy and other people can call it as a god here. So it's very, very important. So generally we are talking, right? We cannot see the god, but we can get experience of the effect of the god. Same way here also. So light itself is a invisible in nature actually, children. We cannot see the light actually. You may get surprised. Sir, how can you say that? We are able to see the light. No, dear children. You are seeing source of light. Yeah, let me tell you one important point here only. For example, you know that light is coming and falling on my face. Can you see the light which is coming and falling on my left? This gap, can you see? No, you cannot see. That's what I am saying. So, dear children, direct light can't be seen. What is the light which we are seeing is the reflected light here actually. It's very, very important. So, light itself is a invisible in nature, but which makes the things visible. Children, we all know very well that light can travel in a straight line. That only we can call it as a rectilinear propagation of light. Always, if we can take any source of light, if we can, for example, let us take here sun. For example, here is sun. So light will go in a straight path only. So light always choose the path so that it should take a less time. So it is possible only with a straight line. It's very, very important. Very, very important. So how to define? This is what actually one light ray of light. But how to define a ray of light? Actually, it's very important. The light traveling in any one direction. In a straight line is called ray of light. You can take any source of light, dear children. The number of light rays which are traveling in any direction, all can go in a straight line. That only we can call it as a ray of light. But how can we represent ray of light? As I said that it is represented with a straight line given particular direction. So children, this is what actually we can show. So it is ray of light. Children, it is not compulsory to show always left to right. It is not that. It depends on the source of light. Okay. The source of light is top. You can take ray of light like this. Of course, even in fact, three-dimensional we can take. But when we talk about particular direction, you can take like this or left to right or right to left. You can take in any direction. But you should represent with a straight line and given arrow symbol. What does this arrow symbol means here? It will show it will give the direction of light. Then dear children, then what about beam of light? Dear children, a group of light rays given out by a source is called actual beam of light. But do you think that whatever the light rays which are given will be always parallel to each other? It is not compulsory, dear children. It is not compulsory. So look at here. Look at it. Let us take one case here where all light rays are parallel to each other. It is like a beam of light. Can you say beam of? Yes, it's a collection of light rays, but in which all light rays are parallel to each other. All are moving parallel to each other. So such a beam of light only we can call it as a parallel beam of light. It's very important, children. Parallel beam of light, where all light rays are parallel to each other. All light rays are parallel to each other. Whereas look at here what is happening from a different position, from different direction, all light rays are coming and they all are meeting at point. All are meeting means they are converging at one point. So the group of light rays which are coming and they are meeting at a common point, is called actually convergent. It's a convergent beam of light. It is convergent beam of light. Whereas dear children, look at here what is happening from a point, so they are going in all directions, they are getting dispersed, so such a beam of light from one point they are originating and in all directions they are going, such a beam of light only we can call it as a divergent light. So dear children, it's very simple to understand this concept. For example, let us take a school here. It's so simple. Let us take here is school. It is a school. So here what will happen? From all directions, students will come to school. All directions, students will come to school, right? But in presence of teacher, how they will be sitting? All are sitting in particular rows, particular lines. They will be sitting. All are sitting in particular lines. Try to understand. But when school time is over, all will get dispersed again. They'll go like this. They'll be going like this. So here we can say that initially morning all students are converged. Okay, and all are sitting in a benches in a proper way, in a parallel lines they'll be sitting. So whereas after school hours, after school time is what will happen? All children will get dispersed. They'll get diverged. So converged means you all are coming to schools and colleges. That is what actually converging to a particular place. And after school hours, you all will be going to your houses to different places. It is called actually diverging. It is called diverging. Children, this is what actually beam of light. I repeat once again. If light rays are parallel to each other, that we can call it as it's a parallel beam of light. Whereas if light rays are coming and they are meeting at a common point, is actually convergent beam of light. Whereas the beam of light in which light rays are going from point to one common point to, they are going in all directions. Such a beam of light we can call it as a divergent light. Children, now we will see actually what is a reflection of light. The question is that, do you think that, dear children, only few objects can reflect the light, such as mirrors and whatever we are calling in a daily life? It is not that, dear children. Every object can reflect the light. Every object. In fact, I can say that the objects which are seen, which are visible, can reflect the light. But difference is that the amount of light which they reflect might be different. For example, let us take this marker. This marker also can reflect the light. My shirt also reflects the light. And this whiteboard also can reflect the light. In fact, our shirts, our bodies, every object can reflect the light. But the amount of it, as I said that, all objects may not reflect the light in an equal manner actually. So it might be different in percentage. This marker may reflect the light, like for example 20%. This board may reflect the light, for example 60%, 60. Whereas you can take a mirrors. Mirrors may, if you can take ideal mirror can reflect the light 100%. But in general, even mirrors also cannot reflect the light 100%. Let us take a 99% they can reflect the light. So before going to understand the concept called reflection of digital, we should understand what is a mirror digital. It's very, very important. So mirror means what actually? When you can try to touch the surface of the mirror actually, you feel it is a very, very, very smooth. Of course, these boards also smooth, but more than this actually is very, very smooth. So a smooth and highly polished surface, only we can call it as a mirror. Here is smooth and highly polished surface, highly polished surface. But can we say that every a smooth and highly polished is not that? One more condition is, what is that? Which should reflect the light, whole light which is falling on it. So a smooth and highly polished surface which reflects the whole light which is falling on it is called actually mirror. Dear children, so it depends on, based on the nature, nature of the reflecting surface, mirrors are classified into two groups here. So here plane mirrors and a spherical mirrors. What is the difference between plane mirrors and spherical mirrors here? Plane mirror in which the reflecting surface is straight, plane. So it will be like this. So plane mirror. So we can represent like this actually, plane mirror. So when you take like this, it is. So it is a silvered here. This part is silvered. This part is silvered. So that this part can act like a reflected surface. This part can act like a reflected surface. Let us say M dash is the plane mirror. Another one is what actually? Spherical mirrors. So the spherical mirrors in which reflecting surface is curved, might be like this. So like this. So it is like inside curved and it will be. So this inner part of inside only we can call it a concave surface. It is convex surface. Based on whether convex surface is silvered or concave surface silvered. Again here spherical mirrors are of two types actually. So here it is concave. Again here we have convex. So regarding spherical mirrors, dear children, in next session we will be studying. So in this particular session we are going to study actually how reflection takes place when light falls in the plane mirrors, what are the terms related and how the image is formed by the plane mirror and what are the characteristics of the image formed by the plane mirror. So before that we will see the types of reflection. Children, what is reflection of light? So in order to understand the concept of reflection of radiation, let us take a small ball here, this one. So just let me throw this ball towards the board. So when I throw ball like this here, so I am throwing this ball towards the board. But the thing is that, is it going through the board? That is it like a penetrating through the wall? It's not that. It is not penetrating through the wall. What is happening? It is coming back. It is bouncing back into the same medium. Now I can say that this ball got reflected. Children, reflection concept is not only belongs to the only light actually. Any object can, even a sound also. When sound falls on surfaces, sound also gets reflected. Sometimes we can call it the resound. We will be talking. The resound is what? It is nothing but resound, echo. These all are reflected sound only. So even sound and any object. So try to understand the concept here. So when this ball is thrown towards the wall, what is happening? It is not going through this. Rather, what is happening? Just it is bouncing back. So like this, in the place of now ball, you imagine the light. When light strikes mirror surface, what happens? It bounces back into the same medium. So that bouncing of light when it strikes smooth and highly polished surfaces such as mirrors is called actually reflection of light. Dear children, here we have two types of reflections. One is regular reflection, another one is irregular reflection. Now first we will see what is a regular reflection and how it is differ from irregular reflection. Children, here we have regular reflection and irregular reflection. What is the regular reflection? When regular reflection will take place? Dear children, when light strikes smooth and highly polished surfaces such as mirrors, as I told you, such as mirrors, then regular reflection can take place. Means here you have to notice one important thing. So here for example, a parallel beam of light is coming and incidenting on a plane mirror. Then what is happening? Of course, after that when this parallel beam of light strikes the plane mirror, it gets reflected, it is sure. But try to observe here one thing. Here in parallel beam of light, a discipline is there. Even reflected light rays also it is going like a disciplinary manner. Means it is also going like a parallel beam of light only. It means the reflected light rays also parallel to each other. Such a reflection is called actual regular reflection. But regular reflection takes place only it strikes very smooth and highly polished surfaces such as mirrors. Now come to the irregular reflection, dear children. So when light strikes not smooth, like rough surfaces, for example the wall or objects. So objects, wall, almost these all are what, dear children, not a smooth surfaces. So what happens here? So it may not happen like this. Rather, look at here. So here also same parallel beam of light is coming and incidenting a rough surface. But look at here, what is happening after reflection? All light rays are not going like a parallel only. These reflected light rays are not parallel to each other. They are scattered in all directions. Here they are coming with a certain discipline. But whereas look at this reflected light rays, they are scattered in all directions. They are scattered. Actually, they are diffused. means they are not going in a particular manner. Such a reflection we can call as a irregular reflection, or we can also call as a diffuse reflection. But dear children, the most of the cases, 19.99%, this is the reflection which is happening. Because this irregular and diffuse reflection only, we are able to see the things. Because when light falls, for example, the light which is coming and falling on my body, it won't like reflected only in this direction. So from all directions the persons can see me, which means what is the light which is coming and falling on me, it gets scattered, it gets diffused. So this is what actually. So again I say addition here, regular reflection will take place when it strikes smooth surfaces such as mirrors, whereas irregular reflection will take place when light strikes like rough surfaces. And one more important thing, dear children, whether light is falling on smooth surface or rough surfaces, it is not a matter. So nature of surface is not matter actually. So whatever may be the surface, dear children, light always obey the laws of reflection. Light always, whether it is a smooth surface or rough surface, it obeys the laws of reflection. That is what angle of incidence is always equal to angle of reflection. Okay children, copy it. Children, now we will see the terms related to the reflection of light. Children, here I shown on board here M dash, let us take it as a plane mirror, and here is PQ is the incident light ray. So what is incident ray? The light ray which is coming towards the mirror and incidenting on the mirror is called actually incident light ray. And children, here it is a point O where the light ray is striking the mirror. So the point O where the light ray is striking the surface is called actually point of incidence O. Very important. Point of incidence. And children, the line drawn perpendicular to the mirror at a point of incidence, is called, let me draw, perfect. The line drawn perpendicular to the mirror at point of incidence is called actually normal. So let us name it as a N dash. Children, you cannot say that the perpendicular line drawn to the mirror. For example, here I will draw perpendicular line. Can be a normal? It is not that. So we have to consider the perpendicular line exactly at a point of incidence. And if you look at here this incident light ray is making certain angle with normal. So the angle made by the incident light ray with normal is called angle of incidence, actually angle of incidence. Then what happens when light strikes the mirror? Obviously it gets reflected. So the light ray which is moving away from the mirror after reflection is called actually reflected light ray. Let us name it as a RS. Even dear children, this reflected light ray also is making an angle with the normal. That only we can call it as a angle of reflection. So the angle made by the reflected light ray with normal is called angle of reflection. But actually one important thing we have to notice, don't you think that here this incident light ray is also making certain angle with the plane mirror? Of course it is making. This angle only we can call it as a glancing angle. Or in some textbooks it will be given as a glance angle, or in some textbook it is given glancing angle also. Anything is okay. So this let us represent as a IG. Why I am representing IG here? Glancing angle of incidence it is. And here even reflected light ray also, which is very important. Even reflected light ray also is making an angle with plane mirror. That angle only we can call it as a glancing angle of reflection. So once again I repeat, the light ray which is coming and incidenting on the mirror, which is coming towards the mirror, is taken as an incident ray, that is a PQ is incident ray, whereas the light ray after reflection which is moving away from the mirror is called actually reflected light ray, and the point where the incident light ray is striking on the mirror is called point of incidence. The perpendicular line drawn at the point of incidence and is perpendicular to the plane mirror is called normal, and the angle between normal and incident light ray is called angle of incidence, and the angle between normal and reflected light ray is called angle of reflection. And children, Even incidental light ray is also making an angle with the plane mirror. Actually, it is called glancing angle of incidence. Whereas here, the reflected light ray also making an angle with the plane mirror. It is called as glancing angle of reflection. Now, we will see the laws of reflection. Children, just look at the diagram here. If you look at here, so this is incidental light ray, it is reflected light ray. And this is angle of incidence, and here is the angle of reflection. Dear children, whatever may be the surface, whether it is a smooth, whether light is falling on smooth surface or rough surface, it is not a matter. Always, angle of incidence is always equal to the angle of reflection. So, this is the first law of reflection. What is that, dear children? The angle of incidence is always equal to the angle of reflection. Dear children, once again I am saying, whether it is a regular reflection or irregular reflection, whether it is a plane mirror or spherical mirror, whatever it may be, always light obey the laws of reflection. That is the first one, is always light obey this rule. That is what? Angle of reflection is always equal to the angle of incidence. Angle of incidence is always equal to the angle of reflection. And here one more point, just look at here, look at the PQ, look at the PQ. So, PQ is incident ray. Even look at the RS, RS is a reflected ray, and look at the normal drawn, normal, that is ON. Children, if you can notice these three, if you can observe this incident light ray, reflected light ray and a normal drawn, these all are lying in the same plane of the board. Look at here. So, do you think that the incident light ray is going like this, so the reflected light ray is coming like this? It's not that. In this diagram I am talking, in this diagram we are talking here. So, this incident ray, reflected ray and normal drawn, these all are lying in the same plane at a point of incidence, it's very important. So, these are the two laws of reflection. The children, now we will see a few examples to understand this angle of incidence and angle of reflection. For suppose it is given, the children, so look at here, it is a plane mirror, such that here is a normal drawn, and here one light ray is coming and striking like this. So, in exam it will be given, so that the light ray is making an angle 30 degrees with a normal, then what is the angle of reflection? Children, from the concept of laws of reflection, we know that angle of incidence is always equal to the angle of reflection. So, what happens? This light ray also gets reflected with the same angle of incidence, that is 30 degrees only. So, you can write as I is equal to R, you can write angle of reflection is equal to 30 degrees. It is fine. Let us take one more example. So, children, here always angle of incidence may not be given. So, look at here. Here is a normal drawn, and here it is a light ray striking. Light ray is striking the mirror in such a way that it is making some 35 degrees. It is making 35 degrees angle with the mirror. Try to understand, children. Now, the light ray is not making angle with the normal. It is making an angle 35 degrees with the plane mirror. Then they will ask us to redraw the diagram by showing the angle of reflection in the figure. It's very important. Children, so this what actually it is given, glancing angle of incidence is given actually. But we know that, children, this complete from here to here is a 90 degrees. If you want to calculate the angle of reflection, we must calculate first this angle of incidence, But, children, can we say that here I plus 35 is 90 degrees? Of course, it is a 90 degrees. So, we can write like this. So, I plus 35 is equal to 90 degrees. So, then here I is equal to 90 minus 35. So, then 90 minus 35 is how much, dear children? It is 55 degrees. 55 degrees. So, here I got now. What is I got here? I got angle of incidence as 55 degrees. Angle of incidence as 55 degrees. Now, according to the laws of reflection, dear children, as angle of incidence is 55 degrees, so light ray must get reflected with the same angle. So, that is light ray also gets reflected like this with 55 degrees angle. Okay, dear children, means here directly angle of incidence is given, then you can calculate directly angle of reflection, no problem. But here angle of incidence is not given, dear children. Glancing angle of incidence is given. So, what you have to do? First, we have to calculate the angle of incidence, then you can get the angle of reflection. But what happens when light strikes like this, dear children? Let us take here. So, here is a plane mirror. Now, light is coming and like this it is striking. Means how it is striking? It is striking perpendicular to the mirror. Then what is the angle of incidence? What is the angle of reflection? So some children, they'll get confused because this is shown very clearly, it is a 90 degrees. So they may take, here chances are there to take a angle of incidence as a 90 degrees, dear children. So let me tell you actually first how to calculate the angle of incidence, from where with respect to what we have to calculate. Children, for suppose it is a normal drawn, let us take this red color mark is a normal drawn. So this black color is its a, let us say it is incident light ray. So this will be the angle of incidence, that is fine. So now try to understand, as this ray is moving towards the mirror, whether the angle is increasing or decreasing. Obviously angle is decreasing. Look at here. For example, it might be now if the light ray is coming like this and striking the mirror, it is a 90 degrees, fine. Now it might be some 70, it might be 60, it might be 50, it might be 40, 30, 20, this one. So now finally what is happening, children? Now now in this case light is, for example, here like this it is striking, it might be like a 5 degrees, but when it moves towards very close to the normal, what is happening? The angle of incidence is decreasing, So if the light falls on the mirror such that it is going along the normal, is there any angle between normal and incident light ray? There is no angle. So what will be the angle of incidence? 0. It's very important. So in this case, dear children, the angle of incidence is not 90 degrees. The angle of incidence is 0. Here you should understand one very important point here. So what is the angle of incidence? The angle between normal and incident light ray. So dear children, so it is a normal and light ray is also falling, means going along the normal only. Then what happens? According to the laws of reflection, dear children, according to laws of reflection, what happens? Angle of reflection should be equal to angle of incidence. Then when it will happen? When its path is retraced back. When its path is retraced back like this. When its path is retraced back, then only what will happen? Angle of reflection also will be 0 degrees. Children, in order to understand this, very simple. So let us take any ball like this. So try to leave exactly perpendicular to the surface. So when this ball is like released like this exactly, after striking this ground, what happened, children? Again it bounces back in the same path. Again bounce back, means its path is retraced. So children, this type of questions can be asked in exam. So what is the angle of incidence and what is the angle of reflection during normal incidence, dear children? So during normal incidence, angle of incidence is 0, angle of reflection is 0. But what is the glancing angle of incidence, dear children? Glancing angle of incidence is 90 degrees. The glancing angle of reflection will be 90 degrees. Because what is the glancing angle? The angle between light ray, it might be incident or reflected with a plane mirror, with a mirror surface, is called glancing angle. But whereas angle of incidence and angle of reflection will be 0. Okay, dear children, copy it. Children, now we will see the image formed by the plane mirror. There, dear children, we will see how the image is formed by the plane mirror. Especially first we will see for a point object. After that we will see for a extended object and what are the characteristics of the image formed also we will see. Dear children, here M dash is a plane mirror. Of course, you can keep in a horizontal direction and you can explain also, it's not a matter here. So let us consider is a vertical position. And here is O is a point size object which is placed in front of a plane mirror. For suppose it is placed, it is a 10 centimeters from the mirror. Example I am saying 10 centimeters from the mirror. Now dear children, in order to make a ray diagram, it's a very important thing. The minimum number of light rays required are 2. So you have to take a minimum number of light rays, how many? 2. Of course, you can take more than 2 also. Children, here first let us consider the light ray which is striking the surface like this. So this light ray is moving towards the mirror, and let us consider one more light ray which is moving like this. Any light rays you can take. It's not compulsory that you should consider only these 2 light rays. You can take any light. Such that they should fall on the mirror. You cannot take light rays which are moving left side. You cannot take because the mirror is placed right side actually. So that is not at all possible. Dear children, what will happen to this first light ray? Let us say the first light ray, the second light ray. And it's already we learned. So how it is incidenting? It is incidenting normal to the mirror. So what happens, dear children? Its path is retraced. its path is retraced back in the same one. But this first light ray appears as if it is coming from behind the mirror. As it is coming from this light ray appears as if it is coming from the behind the mirror. This is what will happen to this first light ray. And what about second light ray, dear children? So second light ray, by obeying the laws of reflection, for example, it is incidenting with a certain angle theta, let us suppose. Theta is an angle. Then what will happen? With the same angle, it gets reflected. So with same angle, it gets reflected. So this is how actually it is getting reflected back. But this light radiation, it appears as if it is coming from this point. As it is coming from this point. So this is a point where image is formed. Image is formed. Let us say this one is a object. So same size should be right. Okay, just wait. So this is a image formed, dear children. Try to understand. So what do we notice? When you can measure this distance, dear children. So even we can find it as a 10 centimeters only. 10 centimeters only. But dear children, here after reflection, do you think that the light rays are meeting actually? No, they are not meeting. When they extended backward, they are appearing to meet. So such a image is called actually virtual image. What is how the virtual image is formed, dear children? So virtual image is formed when reflected light rays extended back so that they appear to meet. It's called actually virtual image. So children, this is how actually the image of points object is formed. So here what we have to notice, just look at the size of the object, dear children. So here point size of the object, point size of the image, which means what? The image size, the image formed by the plane mirror is always equal to the image of the object. And not only that, dear children, so the distance between mirror and object is called object distance. Generally we will represent with the letter U actually. In detail we will be learning in a spherical mirror case. Whereas the distance between mirror and image is called image distance. So if you can observe here, the object distance is always equal to the image distance. So when the object is like 20 centimeters in front of the mirror, then the image is formed 20 centimeters behind the mirror. Okay, dear children, this is how actually image is formed. Now let us see one or two examples so that we can understand. So it will be given question like this. Here is a plane mirror. Okay, here one person is standing in front of the mirror so that the distance is 10 meters. Then what is the image distance? So directly they may not ask you what is the image distance. They will ask you what is the distance between the person and his image. So according to the rules, image also should be formed where exactly 10 centimeters from the mirror. 10 centimeters from the mirror. Now they are asking this total. So what will be this distance between person and his image? It will be 20 centimeters. 20 centimeters. Okay, children, fine. So in the same example, this is what actually. In the same example, we will do one thing. Initially, the person is standing 10 meters in front of the mirror. Now he moved back by 5 meters. 5 meters from his position actually, means from here he moved back, it seems. 5 meters from here to here. Now what is the distance between his new position and image? So now what we have to do, you have to calculate, you have to add this 10 meters plus 5 meters because the person is moving to this point, so that the object distance will become 10 plus 5, it will be 15 meters. Now where the image is formed, even dear children, image also moved away from the mirror. It's very important. Even image also moved away from the mirror and it will be 15 meters behind the mirror. Now what is this total distance? This will be 15 plus 15. So this will be 30 meters. So this is how actually very simple questions are given. Children, now we will see how the extended object image is formed. What is extended object, dear children? Other than point size object. Any object we can call it as actually extended object. Example, this marker is an extended object and in fact we are the extended object. Now look at here, dear children. So here M dash is a plane mirror, dash is a plane mirror, and here AB is an object. AB, like this a marker is placed. AB is a object. Dear children, such a way that here it is from head, let us say it is a tail. From head we are considering, like, let us take a 2 light rays. As I told you that, dear children, the minimum number of light rays are 2, means it can be maximum, it can be infinity. More than 2 you can take any number you can take. So it is the first light ray, it is second light ray, and this will be, let us say, and this will be third light ray, and this will be fourth light ray. So here we have considered 4 light rays. Now we will see how the image is formed and what are its characteristics. We will see. Dear children, this first light ray, as it is presenting normal to the mirror, what happens? Its path is retraced. So it comes back like this. It gets reflected. Let us say it is a 1 dash. Why I am saying 1 dash here? 1 dash is a reflected light ray of this first light ray. Okay, fine. And its third light ray also, as it is incidentally normal to the surface, what happens? Its path also retraced. So it comes back, bounces back. So this will be 3 dash. 3 dash is a what, dear children? Reflected light ray of third light ray. Then what about second and fourth one? These light rays are not incidenting normal to the mirror. They are like it's an oblique incident. So dear children, according to the laws of reflection, with whatever the angle they are incidenting, they are striking the mirror, with the same angle they gets reflected back. So for suppose here, it is, let us say here is a mirror, what we can say, perpendicular, we can make for a mirror. If this will be the, for example, 30 degrees, suppose, with the same angle it gets reflected. So this how actually it gets reflected. This how actually it gets reflected. The same manner. So this will be what, dear children? It is a 2 dash, let me tell. So 2 dash is a reflected light ray of second one. And what about this fourth one, dear children? Fourth one also similar manner. So if it is incidenting with, for example, some 40 degrees or 30 degrees it is incidenting, the same angle it gets reflected back. So this how actually it gets reflected back. Now dear children, do you think that here reflected light rays are meeting or any chance? Of course, no chance at all. There is no chance of meeting reflected light rays. When the reflected light rays are not meeting, what we have to do? We have to extend back. So we have to extend back. So this is extend back like this. Extend back like this. And this light ray also, just wait, we have to extend back like this. Extend back like this. So this is a point and this is 2 points. So where they are appearing to meet. So dear children, so this is will give you size of the image. Children, this will give you size of the image. So here, as I said, AB is object. AB is object. Now let me take it as A dash and a B dash. A dash and a B dash. Dear children, if you can measure this height, for example, this you got, let us say H0 is object height. Here you got as a, for example, I am saying it you got as it's a 5 centimeters. Then what do we notice? We notice that even the image height HI also you will notice as a 5 centimeters only, which means what? The image size is always equal to the object size. Very important. And the children, let us see this object distance. If it is object distance, for example, it is like a 4 centimeters. Then here image distance also 4 centimeters only. Image distance also 4 centimeters only. It's a very important. So this is how actually we can draw the ray diagram for a extended object. Actually, whatever may be the object, so it forms like this only. Okay, dear children. So here 2 points we have to remember. What is that? The image size is equal to the object size, and the image distance, sorry, it is V. So image distance is always equal to the object distance. So for suppose, dear children, in front of this mirror, let us suppose if a letter P is placed like this. Letter P is placed. So do you think that the image appears like this only? No, it's not possible here. So P letter won't appear like this. Rather, it appears like this in reverse. So here what happens? Left appears as a right, right appears as a left actually. This is what actually happen even whenever we are, just when stand in front of mirror, we are combing or something, all these things. What happens? You might have observed that your left appears like a right, right appears like a left. This only we can call it as a lateral inversion. It's very important. Lateral inversion. So now I'll tell you what is actually lateral inversion. We will discuss now. Children, here as I said, here is a mirror. Okay, na? Here letter P is placed here. So just imagine a axis like this passing vertically. This is a axis. So what is happening here? Image is formed like this, right? So during this lateral inversion, what is happening initially? This image, the object means, especially let us talk about the image. This image is rotated through 180 degrees. 180 degrees around the axis which is passing vertically. So this is being rotated. This is being rotated. So try to understand by how much, dear children? It is a 180 degrees. Children, now we will see the characteristics of the image formed by plane mirrors. The first one, what we have to, very important. So it will give you virtual. This is very important. It's a virtual. Means what? After light rays, if a light rays are after reflection, children, if reflected light rays are meeting, it will give you actually real image. But in the case of plane mirror, the reflected light rays are not meeting. Rather, they are appearing to meet when they extended back. So such a image is called actually virtual. So plane mirror will give you always virtual image only. And the second one is upright, or you can say it is a erected also. You can say it is a erected also. And third one is very important. What is that here? Image height or object height is always equal to the image height. It will give you same size of the object. Will give. If the object size is 10 centimeters, image size also will be 10 centimeters only. And the fourth one, dear children, image distance is always equal to object distance. If you are keeping one object 10 centimeters from the mirror, 20 centimeters, for example, let us say 10 centimeters from the mirror, then image is formed behind the mirror 10 centimeters only. And mostly the image is laterally inverted. So, dear children, in this session, what we have learned? So we have to learn the basic point of actually reflection. What is a reflection and what are the types of reflection? There we have studied regular reflection and irregular reflection. Then we studied the characteristics of the image formed by a plane mirror. There we discussed point size object and we discussed even extended object also. In next session, we will be discussing the number of images formed by a plane mirrors. When two plane mirrors are arranged certain angle. So what are the number of images formed? Then how to find out the number of images and how to draw the number of images formed by the plane mirrors when they are arranged, especially two plane mirrors when they are arranged at a certain angle. That is going to be a very interest. Thank you so much, dear children. All the very best.